So this is a chapter 9 review for test. It's a Pear deck. You can write on the Pear deck. You can do it on a piece of paper. It's just practice for our test, which is going to be on Thursday. So for this first one, put a point in the corresponding location on the unit circle, label the corresponding coordinates, and find the exact value of cosine of 5 pi. So just a little reminder, when we are doing this, over here, let me get over here where I did it in pink, that's all my even pi's, 2 pi, 4 pi, 6 pi. The one I'm doing in blue here, this is all my odd pi's. So we are going to be at the blue one. So that one's gone. And then the coordinates of this point are going to be -1. Let me get this a little smaller. -1, 0. And so cosine is the x coordinate. So the answer to this is going to be -1. That is our answer, -1. On the next one, we're doing the same thing, but this time it's for cosecant of -5 pi force. And so when we are trying to go to -5 pi force, we're going to be going this direction, okay? To here would be -4 pi force. To here would be -5 pi force. So we're going to have a point right there. And the coordinates of that point that's going to be -√2/2, comma, +√2/2. And we want to find the cosecant of this. Now, the reciprocal of a cosecant, remember, C doesn't go with C, S doesn't go with S. So since this is a C, the reciprocal is going to be sine. So we basically want sine of -5 pi force, and then we're going to take the reciprocal of that. So the sine of -5 pi force is going to be √2/2. So we want the reciprocal of that. So the reciprocal of that is going to be 2/√2. I'm going to rationalize that, which means I'm going to times the top and bottom by √2. And I'm going to get 2√2/2. And I can reduce that down to √2. So the final answer for that is going to be √2. The next one, tangent of 7 pi 6. So tangent of 7 pi 6. As we're going around all the way to here would be, for example, 6 pi 6. We want to go one more, so we're going to be right there. That is going to be 7 pi 6. And the coordinates of that point, it's going to be, and the way I think about it is long, comma, short. So long is my -√3/2. Short is my 1/2. Now tangent is y over x. So I'm going to take 1/2 over negative, and actually both of these are negative, I apologize. -1/2 over -√3/2. So that's going to be a -1/2 times the reciprocal of a -2/√3. My 2's are going to cancel, and I'm going to get a positive, because it's a negative times a negative, 1/√3. I'm going to rationalize. I'm going to multiply the top by √3 and the bottom by √3. And when I do, my final answer, I'm going to write it in blue over on the left side, is going to be √3/3. That is my answer. Now this time we want to figure out the locations where my unit circle will be, well, on the unit circle where my sign is going to be a -1. So sign being a negative is going to occur in the bottom two quadrants. So we're going to be down. Let me start again with that. We're going to be down in these bottom quadrants here. Okay, so 3 and 4 is where my sign is negative. And I want a -1. And so I am going to have a -1 down here at that point. Okay, that point right there. And the coordinates of that point, it's 0, -1. But what I want is the radian. And the radian for that is going to be 3 pi halves. And that is the answer. On number 5, same idea, but this is a secant. Now remember, S doesn't go with S. So the reciprocal of a secant is a cosine. And I really want to know if my secant is a -2, that means my cosine is the reciprocal, which is a -1/2. So I want to figure out where my cosine is negative to start with. And my cosine is negative in quadrants 2 and 3. So this is where I'm going to focus myself. And I want my cosine, which is my x, to be -1/2. So I'm going to be thinking short, long. So I'm going to be up at this point here and down at this point here. Now the coordinates of that, the top one here is going to be a -1/2, √3/2. The bottom one is going to be a -1/2, -√3/2. But what I want, and I'll write it in blue, is the radians. So the radian for the top one is going to be 2 pi thirds. The radian, so that's this one here. The radian for the bottom one is going to be 4 pi thirds. So my two answers are going to be 2 pi thirds and 4 pi thirds. Okay, so now cotangent. Cotangent and tangent are both negative. Sorry, are both, well, so I want my cotangent, this is not a positive or negative, this is a non-positive and non-negative. So I want where my cotangent is 0. Now cotangent is x over y. So for my cotangent to be 0, that means my x has to be 0, okay? My x is going to be 0. My numerator is going to be 0. And so my x is 0 at 2 spots, here and here. This is up at 0, 1. This is down at 0, -1. And the top one is going to be pi halves. And the bottom one is a 3 pi halves. So our two answers are pi halves and a 3 pi halves. Okay, so for this one, we're going to graph. My amplitude is 2. My vertical shift is a +3. We're going up 3. My period is going to be a 2 pi divided by 5. And my phase shift is going to be pi force. Now, I am going to be starting at pi force, and I'm going to be going 2 pi fifths away, which means I'm going to have 5 pi 20ths plus 8 pi 20ths, which means our graph's going to end at 13 pi 20ths. So for the graph, I'm going to drop it down. We're going to be starting at 3. We're going to be going 2 above that, which is a 5, 2 below that, which is a 1. And so when I'm doing this, here at 5 and at 1 will be my high and low. Here at 3 will be my zeros. Now, scaling my x-axis, we're going to be starting at pi force. I'm going to go 1, 2, 3, 4, 5. And we're going to be ending at 13 pi 20ths. Now, when we're doing this, my sign, I start at 0. Let me make this a little bigger. I start at 0, I end at 0. Halfway in between will be my 0. And then since this is negative, I'm going to go down and then up. And here is my sine graph. Okay, on this next one, my amplitude is, let's see, was this the same one? Hold on. Oh, this was the same one. Let's skip over this. So for number 3, and here, I'm going to pause this. I'm going to put a new one up here. Okay, so 7b and 8b were both copies of the same sine and cosine graph, so I changed it. So this is going to be the new 7b. And so on this one, our amplitude is 5. Hold on, let me. Our amplitude is 5. A little thicker. Our vertical shift is going to be -3. Our period is 2 pi thirds. Hold on, let me get rid of that. Okay, so 2 pi thirds. Our phase shift is going to be pi 6. Okay, so now when I'm trying to figure out where we're going to start and stop, we are starting at pi 6. We are going to be going 2 pi thirds away. That means pi 6 plus 4 pi 6. And we're going to end 5 pi 6. So in this graph, we're going to be dropping down to -3. We're going to go 5 below that, which is going to be -8. We're going to go 5 above -3, which is going to be 2. And we're going to end up with a high and a low at 2 and -8. And our vertical shift is going to be here at -3. Now we're going to be having 1, 2, 3, 4, 5 marks. And the first one is going to start at pi 6. The last one's going to end at 5 pi 6. This is a sine graph. It is a positive sine graph. So sine starts at 0, ends at 0, halfway in between the 0. Then since it's a positive, we're going to go up and then down. And that, oops, hold on, let me draw that part a little better. Is going to be our sine graph. On 8a, our amplitude is 3, Our vertical shift is down 2. Our period is going to be 2 pi over 2, which is pi. And our phase shift is going to be pi 6. So we're going to be starting at pi 6, going pi away. So we're starting at pi 6, and we're going to be going basically 6 pi 6 away, which is going to put us at 7 pi 6. So when I draw my graph, I am going to be starting down at -2. We're going to go 3 below that, which is -5. We're going to go 3 above that, which is going to push us up to 1. And my highs are going to be at 1. My lows are going to be at -5. And my vertical shift, which are going to have my zeros, is at -2. So when I do this, I'm going to have 1, 2, 3, 4, 5. I'm going to be starting at pi 6, ending at 7 pi 6. This is going to be our cosine. Cosine starts at the high, ends at the high. Halfway in between is the low, and then in between those are going to be our 0. And that is going to be our cosine graph. Next one, amplitude is 4. Vertical shift is a +2. Period is going to be 2 pi thirds. And our phase shift is pi fifths. So we're going to start at pi fifths. We're going to go 2 pi thirds away. So that's going to give me 3 pi 15ths plus 10 pi 15ths, which is going to push me to 13 pi 15ths. And so we're going to have our graph. We're going to be starting at 2. We're going to be going 4 above, which is 6. We're going to be going 4 below, which is at -2. Our highs are going to be at 6, and -2 is our lows. Our vertical shift is going to be at a +2. I'm going to have 1, 2, 3, 4, 5 marks. We are going to be starting at pi fifths, and we're going to be ending at 13 pi 15ths is where that last mark is. And this is a negative cosine, so negative cosine is going to start at the low, end at the low. Halfway in between is going to be our high, and in between those are going to be our zeros. And let me just get this a little smaller. And then this is going to be our cosine. On this one, we're going to be writing a sine and a cosine equation. So this one we want to write a sine and a cosine graph. So my highs are at 4. Our lows are at 0. And our vertical shift is going to be here at 2. So right away, I know that my K in my equation, my K is going to be 2. I also know my amplitude is going to be 2 because I'm going 2 above and below that green line. So that's going to be 2. For this, I'm going to try to find a nice point for me to start on and end on. And I'm also going to try to find nice values for me to figure out my period. So I think in terms of writing a sine graph, I would like to start here because I know that value. And then in terms of me doing a cosine, I think I'm going to start my cosine up here. I think that's what I'm going to do. Now, I also need to figure out the period for this so that I can figure out my b. So for this, I'm trying to find values that are easy for me to distinguish. So what I notice is this low right here is going to be at a negative pi halves. And this over here is at a 3 pi halves. The distance from between those 2 points is going to be from here to here is pi halves, another pi halves, so that's pi. So each one of these is a pi halves. So this is 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, and 4 pi halves is really 2 pi. So within 2 pi distance, I have, let me see, 1 complete cosine, 2 complete cosines, 3 complete cosines. That's actually going to be my b, because my b is how many complete cycles I have within 2 pi distance. So I have 1 cosine, 2 cosine, 3 cosines within that 2 pi distance. So my b is going to be 3. So now I can start to write my equation. So from my pink, I'm going to be doing a negative sign. Okay, so that's what I'm going to be doing my sine graph. Okay, and so my sine is going to be y equal. This is a negative sign, so it's going to be a negative, and my amplitude is 2, so -2 sine. My b is 3. I'm starting on my y-axis, so I don't have a phase shift. And then my vertical shift was +2. Now for my cosine, I'm going to start my cosine here, and I'm going to go to here. So for my cosine, this is going to be y is equal to, this happens to be a positive cosine, so it's going to be a +2 cosine. My b is still going to be 3. I'm starting at pi halves, so this is going to be an x minus pi halves, and then +2, and that's my equation. Okay, so on this situation, this is the Tarzan problem. We've kind of seen this before. So let's pay attention to what's happening. When we have this problem, Jane is starting the stopwatch at 5 seconds. Tarzan's at y equal -18. At 9 seconds, we're at y equal +13. That is our high and our low. So when we are doing this graph, we need to get up to 13. We need to get down to -18. Halfway in between is going to be our vertical shift. And so if I add those together, which is going to be a -5, and divide by 2, I get a -2.5. And then there will be my x-axis. Okay. So this is going to be the high. This is the low. And this is going to be our vertical shift. Now, in terms of this, I've got my first mark is going to be 5. And Then I've got 1, 2, 3, 4, 5. At 9, we're going to be at a 13. And then, so what's happening here is I'm going to be at 5, we were at negative 18. At 9, we're at 13. So this is going to be the look of our graph. It's going to be a negative cosine. And if I was from here to here, that's going to be a distance of 4. So I'm going to go 4 beyond that, which means that this is going to be at 13. And then this is going to be our cosine graph. So our equation for this, it's a little bigger, is going to be y equal, it's going to be negative cosine. The distance from here to here is going to be a negative 15.5. So it's going to be a negative 15.5 cosine. My b is going to be determined by figuring out my slope. I mean, not my slope, sorry, my period. My period from here to here is going to be 8. So I am going to take 2 pi divided by b equal 8. When I work that out, I get 2 pi eighths is equal to b, or pi force. So this is going to be a pi force. I'm starting at 5, so this is going to be an x minus 5. And then my vertical shift is a negative 2.5. And that is our equation. Okay, on 11, we want to be looking at our P's and Q's. So our P's and our Q is going to come from here, which is going to be plus or minus 1. So that is going to give us a plus or minus 1. And this is going to give us a plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Now, since all these are over 1, it's really going to end up having my P's over Q's be these. Those are the ones that I'm going to start. Okay. And find. So on this, when I am dealing with this, I am going to do synthetic division. I'm going to have 1, 1, negative 5, negative 3, 6. Let's say I start with 1. Bring down my 1. 1 times 1 is 1. I add it to 1, I get 2. 2 times 1 is 2. I add it to negative 5, I get negative 3. Negative 3 times 1 is negative 3. I add it with negative 3, I get negative 6. Negative 6 times 1 is negative 6. I add it to 6, I get 0. So I found one solution. One solution is going to be x equal 1. So now I'm going to do a new synthetic division with a 1, 2, negative 3, negative 6. Let's say I try 2. Bring down the 1. 1 times 2 is 2. I add it to 2, I get 4. 4 times 2 is 8. I add it to negative 3, and I get 5. 5 times 2 is 10. I add it to negative 6, it is 4. Since I got all positive numbers here, when I started with a positive 2, I've hit an upper bound. So I need to go a different direction. So let's say I go and try negative 1. Bring down my 1. Negative 1 times 1 is negative 1. I add it to 2, I get 1. Negative 1 times 1 is negative 1. I add it to negative 3, I get negative 4. Negative 4 times negative 1 is 4. Add it to negative 6, I get negative 2. Okay, let's try negative 2. Negative 2 times 1 is negative 2. I add it to 2, I get 0. 0 times -2 is 0. I add it to -3, I get -3. -3 times -2 is 6. I add it to -6, I get 0. So I found another solution. X is equal to -2. So now I'm going to take what I just got left with, which is x squared minus 3, set it equal to 0, and solve. So this is going to be x squared is equal to 3. I take the square root, and I get a plus or minus root 3. So my last two answers are positive, negative, root 3. And a little reminder, since this was a degree 4, you're going to get 4 solutions, and we did. This one, what I'm going to do is I'm going to take the cube root of this, which is 7x, plus I'm going to take the cube root of this, which is 5. Then I'm going to take this and I'm going to square it, which is a 49x squared. And I'm going to change the sign. Since this is a plus, this is going to be a minus. Then I'm going to multiply these together, which is going to be a 35x. Then I am going to square this, which is going to give me a 25, and that's our answer. 7x plus 5 times the quantity 49x squared minus 35x plus 25. On this one, we want to get same base. So my 8 is a 2 cubed, and that's raised to the 2x minus 3, and power to power we're multiplying, so that's why I'm writing it like that. 16 is a 2 to the 4th, and that's going to be raised to the x plus 10. Now, when my bases are the same, and both of these are equal to each other, the exponents have to be equal. So I basically have 3 times 2x minus 3 has to equal 4 times x plus 10. So I'm going to get 6x minus 9 equals 4x plus 40. I'm going to minus 4x, so I get 2x minus 9 is equal to 40. I get 2x is equal to 49. And I get x is equal to 49 over 2 as the answer. And on this one, when we have logarithms, we want to get this side to be a single logarithm. So I need to make that into a single logarithm. And since it is a plus here, what happens is I'm going to take log base 2 of, and then this x is going to multiply with this x minus 2. And that's going to give me an x squared minus 2x. And then that is going to equal 3. So now what's going to happen is I'm going to rewrite this in exponential form. So I'm going to take the base, set it equal to the power, and log is always equal to power. So that's going to be my power. So I get 2 to the 3rd is equal to x squared minus 2x. I get 8 is equal to x squared minus 2x. I get 0 is equal to x squared minus 2x minus 8. I'm going to factor that. So I'm going to get an x minus 4 and an x plus 2. Let me scoot it over a little bit. So again, I'm going to get an x minus 4 times an x plus 2 is equal to 0. I get x is equal to 4, and I get x is equal to -2. And remember, we have to check back into the original problem, and I cannot be taking log of 0 or a negative number. So when I am looking here, I am looking at this x and this x minus 2. And when I put x equal 4 in, that's going to be okay. So that's going to be an answer. But when I put x minus 2 in, I'm going to be getting negative. So that one is not going to be an answer. And that's the end of this video.